think about it. The smartphone in your pocket, the electric car you just drove past, the very power grid that keeps our lights on. Our entire modern world is built on systems designed by electrical and electronics engineers. But what does that job really look like today, in 2025? Well, let's dive in and find out.
So, let me ask you a question. When you picture an electronics engineer, what's the first thing that pops into your head? Is it that classic image, right? Some lone genius hunched over a workbench, soldering iron in hand, surrounded by a chaotic mess of wires and blinking lights? For a long time, that was pretty much the stereotype. But the reality today? It looks a whole lot more like this. It's so much less about tinkering by yourself and way more about orchestrating these massive interconnected systems. The modern engineer is really more of a conductor of a high-tech orchestra than a solo musician.
And that's because the engineer of 2025 is a true hybrid. They've moved way, way beyond that workbench. Today, the role is this dynamic mix of being a designer, a coder, a collaborator, and even a high-level strategist, all kind of wrapped up into one.
So to really get a feel for this, we're going to walk through a typical day, and we'll break it down by looking at the 3 core challenges that every single modern engineer has to tackle to bring an idea into the real world.
So here's the game plan for the day. It splits pretty cleanly into 3 big chunks. The morning is all about the alignment challenge. Then midday, you're wrestling with the complexity challenge. And the afternoon, that's dedicated to the perfection challenge. Let's take a look at each one.
The day doesn't start with a soldering iron. It starts with people. The first big hurdle is just getting everyone on the same page. That's the alignment challenge. This means team meetings, it means hashing things out with AI specialists and software devs, and it means making sure you're perfectly in sync with all the stakeholders. So in the morning, your most powerful tool isn't hardware. It's just really, really good communication.
Okay, now we get to the deep technical work. Midday is all about tackling pure complexity. This is where engineers are diving headfirst into CAD software, designing and simulating these incredibly intricate circuits. And more, they're using AI and automation to help them do it. This is also when you see physical prototypes getting built and tested. The key skill here, it's not just about knowing the formulas, it's about technical creativity. And then comes the afternoon. This part of the day is a straight-up grind. It's the pursuit of perfection. This is where you get into that loop of troubleshooting weird problems, optimizing every little thing for performance, for efficiency, for cost, and then doing it all over again based on test results. It really just demands relentless problem-solving. Now, that midday complexity challenge, it's getting exponentially harder every single year. There's this massive problem in the industry called the design productivity gap. And what that means is the complexity of a modern chip is growing way faster than a human being's ability to design it. So how do we possibly keep up? Well, you bring in an AI co-designer. And just look at the difference here. The old way was a slog. Engineers had to manually write these long, complicated scripts to tell the design software what to do. It took forever, it was super easy to make a mistake, and it just didn't scale. But the new way, it's a game changer. Engineers can just type out what they want in plain English, and an AI figures out the best way to do it. It's just faster, smarter, and way more efficient. This entire world of design software has a name: Electronic Design Automation, or EDA. The easiest way to think about it is like AutoCAD, but for microchips. It's incredibly powerful stuff. But as we just saw, the old way of using it, with all that custom scripting, was becoming a serious bottleneck.
And this is how that new workflow actually plays out. It's pretty amazing. It starts with the engineer just stating a goal, like they're talking to a person. Then an AI agent, a large language model, figures out what that means. The agent then generates the perfect, optimized script and passes it off to the big commercial EDA tools to do the heavy lifting. The engineer's job has shifted from being a low-level coder to a high-level director.
So you've got all this daily work, right? The meetings, the intense design sessions, the AI-powered tools. But what's the point? What does it all actually build? Well, it adds up to pretty much every piece of technology that's shaping our future. I mean, their impact is literally everywhere. In the car world, they're building the guts of electric vehicles and the chargers that power them. In renewable energy, they're designing the solar grids and wind power systems we need to save the planet. And of course, consumer electronics and aerospace, none of that would even exist without their work. You know, an engineer's day doesn't happen in a vacuum. It all fits into this much bigger picture, the product development lifecycle. It's this whole journey,
from a simple idea all the way through designing the architecture, prototyping, and finally getting it ready for mass manufacturing. That work in the middle of the day and the afternoon, the complexity and the perfection, that's the engine that drives this entire process. We've talked about a lot of high-tech tools, CAD software, AI assistants, the whole 9 yards. But what if I told you that one of the most crucial tools for a modern engineer is probably something you already have on your computer right now? Let's get a little reality check from folks who are actually in the trenches doing this job. So, what do you think? What is this essential, non-technical tool that's the real bridge between a brilliant engineering idea and a successful product? And there it is. According to Reddit user Gust334 on the electrical engineering subreddit, it's a frightening amount of PowerPoint. Yeah, you heard that right. And honestly, a ton of other engineers agreed. It might sound like a joke, but it points to a much deeper truth about the job. This is what people in the industry have started calling slideware. And look, it's not busy work. These reports, these presentations, all this documentation, it's an essential engineering function. It's how you explain a super complex idea to a non-technical manager. It's how you track progress, and it's how you document everything so it can actually get built and maintained. Okay, so let's put it all together. You've got intense collaboration, mind-bending technical problems, AI co-pilots, and yeah, even a whole lot of slideware. So what does it actually take to succeed in this field? What are the skills you need for this next frontier of engineering? It really comes down to a balance. On the one side, the technical skills are completely non-negotiable. You have to have a deep understanding of circuit design, you need to get AI and IoT, and you need expertise in huge areas like power systems. But, and this is the big but, all of that is worthless if you don't have the soft skills to match: clear communication, the ability to work with people from totally different fields, and solid project management. The engineer of 2025 has to be a master of both sides of this coin. And this brings us to one last big question to think about. As AI gets better and better at handling the routine, complex design work, what's left? What becomes the most valuable, uniquely human skill that an engineer brings to the table? Is it pure creativity, big picture strategic thinking? Or maybe it's just the ability to ask the right questions in the first place? That's definitely something worth chewing on.